Controversial three-parent baby treatments could be introduced in the UK as early as next spring. This comes after the treatments have received the green light from an independent panel of experts today. Scientists cleared away remaining safety hurdles to recommend cautious adoption of mitochondrial replacement therapy for devastating inherited diseases. Babies born after the treatment would effectively have three genetic parents. A tiny proportion of their DNA would come from their mother, father and a third person, an egg donor. The aim is to replace abnormal genes in the mitochondria, rod-like power plant in cells that generate energy. Following the fourth and last report from the expert panel, it is highly likely Britain's fertility regulator, the Human Fertilization and Embryology Authority, will now give the go-ahead in principle for mitochondrial replacement to enter the clinic. The HFEA will consider the issue at a pivotal meeting on December 15, when it will decide whether clinics may make applications to offer the treatment. If it agrees with the scientists, the first few women could undergo mitochondrial replacement therapy as early as March or April next year. The mothers undergoing the untried procedure would be acting as guinea pigs, whose experiences will be written up in scientific journals. Scientists at the University of Newcastle, which pioneered mitochondrial replacement, are poised to submit an application to the HFEA. It is understood the regulator will look at applications on a patient-by-patient basis. We think that the cautious approach to the use of mitochondrial donation in treatment that we recommend strikes the right balance between offering access to this exciting new treatment to couples at real risk of having a genetically related child with mitochondrial disease, while doing all we can to ensure that the treatment is safe and effective. Dr. Andrew Greenfield, who chaired the expert panel and is an HFEA board member, said mitochondria only hold around 0.1% of a person's DNA. It is always inherited from the mother and has no influence over individual characteristics such as appearance and personality. It is quite separate from the DNA in the cell nucleus, which houses the vast majority of an individual's genes. But when mitochondrial DNA goes wrong, the results can be catastrophic, leading to a wide range of potentially fatal conditions affecting vital organs, muscles, vision, growth and mental ability. Mitochondrial replacement, conducted by fertility doctors, involves removing faulty mitochondria and substituting healthy versions from a donor. A baby boy was born to Jordanian parents earlier this year using the controversial technique. It is carried out by transferring the genetic material that effectively encodes a baby's identity to a donor egg whose own nuclear DNA has been removed. Two different techniques may be employed either before or after fertilization. The end result is the same: an embryo containing healthy mitochondria from the donor and nuclear DNA from the baby's mother and father. In theory, mitochondrial replacement can not only prevent a child developing inherited diseases, but also protect future generations. Last year, the UK became the first country in the world to legalize mitochondrial replacement after MPs and peers voted in favor of allowing it. A key point considered by the expert panel was whether mitochondrial replacement had any advantage over pre-implantation genetic diagnosis. This technique is used to screen IVF embryos for genetic defects so that only healthy ones are selected for transfer into a mother's womb. But even with PGD, a certain amount of abnormal mtDNA can slip through. For women with high levels of abnormal mtDNA, the procedure was not an option, the panel decided. The scientists said PGD might be appropriate for less affected women, but would always be no more than a risk reduction strategy. They also looked at the chances of disease-causing DNA sidestepping mitochondrial treatment. Research has shown small amounts of mtDNA, below 2%, could be carried over and end up in the donor egg. This was too small an amount to cause any problems, but stem cell experiments show that in a few cases the carried over mtDNA multiplied and increased during embryonic development, a phenomenon known as reversion. The panel concluded that reversion did not pose a serious risk and pointed out that prenatal screening techniques would be able to pick it up before a woman gave birth. This is obviously great news with the report conclusions, said Professor Doug Turnbull from the University of Newcastle. This gives women who have mitochondrial DNA mutations reproductive choice, and I am delighted for them. In proceeding to the next stage of this exciting research, it is still important to remain pragmatic and move cautiously in following the review's thoughtful recommendations, added Dr. Rob Buckle, Director of Science Programs at the Medical Research Council. The implementation implementation of any new treatment in humans always presents some risks. But a strong regulatory and governance framework overseen by the HFEA will mean families and their doctors can decide whether the potential benefits outweigh these risks.